morning, dear friends. I am Dr. Linus from Sanjay Godawat University, Kolhapur, Maharashtra. In the last class, we come to know the ideal characteristics of different switches and the switching time and switching frequency with two activities as well. Those who have not subscribed this channel, kindly subscribe. Today's lecture, we are going to learn about different types of switches used for power electronics with the activity to know the terminals of the power switches in the Genomio. Let us see the outcome of this today's session, especially the types of power switches. The first outcome is to explain the types of switches based on the control, direction of current flow, layers, junction and number of terminals and control signals. Then we understand the different terminals and symbols of power switches with one activity. These two are the main outcome. Let me explain first the types of power switches. Based on the layers, the power switches are classified into three categories. Based on the layers, we know already semiconductors are there, P type, N type. So if we have two layers, we will have one junction. So like that, based on the layers, we are having three types of switches. First one is two layer switch, three layer switch and four layer switch. That means two layer means one junction, three layer means two junction, four layers means three junctions, switches. So let me see the what all the switches are under this two layer category. Diodes are normally two layers category. So two layers and only one junction. Then for this three layer category, we can see the transistors family all are in the three layer category. Then four layer category, thyristor families all are in the four layer category. So two layer diodes, three layers transistors and four layers thyristors. Let us see what all the different switches are under transistors family. First one is BJT. You can see below here what is the full form of BJT? Bipolar junction transistor. Then IGBT, insulated gate bipolar transistor, and then SIT. SIT is nothing but static induction transistor. Then finally MOSFET, metal oxide semiconductor field effect transistor. So these are all come under transistor family. Then thyristor family, first one is diac. Diac is nothing but diode for alternating current, diac. Then SCR is nothing but silicon controlled rectifier. Then third one is SITH. SITH means static induction thyristor. Then MCT means MOS controlled thyristor. GTO means gate turn off thyristor. Then triac means triode for alternating current. So these are all come under thyristor category. So transistor category BJT, IGBT, SIT and MOSFET. Thyristor category triac, GTO, MCT, SITH, SCR and diac. Then if you see the based on the terminals, what are all the power switches, if you analyze, we will have two types based on the terminals. First one will be two terminal and second one will be three terminals. Let us see what are all the switches come under two terminals. First ones we know diode. Then second one will be diac. Diac in the sense diode for alternating current. So these two are come under two terminal. Then three terminal, if we see transistors and thyristors family, all the switches are come under three terminal except diac. Except diac, triac, GTO, MCT, SITH, SCR all are having three terminal switches. So these two are two terminal, these families are three terminal except diac. Okay. Then let us see based on the control. The switches are classified as three types: uncontrollable, semi-controllable and fully controllable. Some switches we cannot control, that's why it is called as uncontrollable. Some switches we can control, that means we can switch on and switch off. Switch on it will be in our hand, switch off it will not be in our hand. We cannot control some extent that whenever some of the supplies DC supply, we cannot switch off the particular switches. We should have separate circuit for switch off that. That's why it is called as semi-controllable. Fully controllable means we can switch on and how much period it should be on, then how much, when we have to off, everything can be controlled by using the full controller. So uncontrollable means we cannot control at all. Semi control means we can switch on but we cannot switch off. But fully control means we can switch on, control and switch off also we can do that. Then let us see what are the uncontrollable. Diode and diac are uncontrollable. Even the previous when we learn about the ideal characteristics also we have learned this, right? Uncontrollable. Then semi-controllable means SCR and triac are the semi-controllable. We can control, we cannot fully control, we can half. That is why it's called as semi-control. Fully control, we can do SITH is fully controlled, MCT, GTO and type transistors all are fully controlled. So this is what we have to be understand about the based on the control how the different types of we can segregate the power switches. The next one, direction of current flow. Under the direction of current flow, based on the direction of current flow, switches are classified into two types: unidirectional and bidirectional. What is meant by unidirectional? The current will flow from one side to another, anode to cathode. Cathode to anode, it will not be possible. That's why it is called as unidirectional. Even ideal switches, drawing the ideal characteristics, we have learned that. Unidirectional. Bidirectional in the sense both the direction, from left to right as well as right to left, or maybe from one terminal to another, then another terminal to the previous terminal. So we can current can flow. That's why it is called as bidirectional. Both the direction current will flow. Let us see what all the switches are coming under unidirectional. First one will be SITH, MCT, GTO and SCR, all are unidirectional. You can include diode also. This is also unidirectional. So you can see the unidirectional switches: diode, SCR, GTO, MCT, SIT, all are the unidirectional. Plus another one, this one BJT, MOSFET, all also unidirectional. The different things we will learn it later separately, each switches how the characteristics will be. First you should understand the things, direction of current flow. Just you note down this: unidirectional, SCR, GTO, MCT, SITH and BJT, MOSFET and MOSFET, IGBT, all are unidirectional. Then bidirectional, that's what I have drawn: diode, transistor, all transistor family will come under IGBT, all will come under the unidirectional. Okay, so transistor family switches: diode, SCR, GTO, MCT, SITH. Then bidirectional, diac and diode, all are the bidirectional. So diac and so bidirectional, if you see, diac and the triac are the bidirectional. So I hope you understand what all the switches are unidirectional, what all the switches are bidirectional. Let us see the last types of category. Based on the needs of control signal, switches are classified as some switches require continuous signal, some switches require pulsating signal. So, for example, continuous signals are required to switch on the switch in all the time. SIT, IGBT, MOSFET, BJT all are required continuous signals. Then pulsating signal, GTO, MOSFET, MCT and SCR are all the required pulsating signal. We know not required continuous signal all the time. Once pulse is sufficient to trigger the switches. So this what we have to be. So we have learned different types. First one is based on the control, based on the layers. Then second one will be based on the terminals. Then third one will be based on the control. Fourth one is direction of current flow. Then last one is based on the needs of control signal. Let us do the activity in order to understand the terminals, different types of terminals, and how the position of the terminals and what is the symbol of the terminals. Let us move to the activity. When you go to the Genomio, under module 1, you can see that today's activity is 1.4 to know the terminals of the main power switches. You can click on this. If you see here, we can have 1 to 24 doors. This is called as advent calendar. So if you open the door, out of these 24 doors, you will have 8 switches are placed in the different doors. Your job is, in each door, you have to open it and select in which door the power switches are there. Then in the particular door, which type of power switch. For example, SCR means you can write SCR, first door SCR. Then example I am saying first door SCR and the terminals of the switch. So what are the terminals? Based on the switch configuration, there is having different terminals of the switch. So like that you should mention. Also you have to understand the position of the terminal as well. Best example I will tell you the first one. First door is having the switch. If you don't know the switch name, you can, if you go and move the cursor near to the image, you will get it. Silicon control rectifier. So symbolic representation of silicon control rectifier is like this. So the 3 terminals, anode, cathode and gate. Then when you close and if you go to this image, you can see here cathode, anode and gate. 3 terminals are there, cathode, anode and gate. This will give you the position of the terminal. This will give you the symbol of the switch so that you can understand what type of switch it is. Similarly, some cases if you go for example 5th door, nothing will be there. So that means there is no switch at all. So like that, each door you should go 1, 2, 3, 4 like that till this 24, and what your work is like this. Go to the command window of this YouTube and select for example first door having switch off silicon control rectifier. So first door silicon control rectifier, terminals are cathode, anode and gate. Like that you should mention. This activity will help you to understand what are the main switches in power electronics, then what are the terminals of each switches, how to name the switch terminals, and what are the positions and symbol as well. I hope you are very much comfortable with the different types of switches, different categories, and you enjoyed the learning through this calendar activity. The people who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.